All right, we got a confession. We didn't give you the complete version of a couple basic derivative rules, like, check this one out. The derivative of sine of x is not cosine of x. We actually did the chain rule, right? So we took the derivative of sine of x and we got cosine of x, but we forgot to multiply by the derivative of the inside, right? The derivative of cosine of x, though, derivative of x is just 1. So that's why it worked out, because we just had 1x. But what if we had 2x or 5x or x squared on the inside, right? Then we should write our function like this. The derivative of sine of u of x. U here just so happened to be 1, so the derivative of u worked out. Applying the chain rule, we get the derivative of sine of ux to be u prime of x times the cosine of ux. Same thing here, right? We kind of lied to you about this one too. Don't tell your parents. The derivative of a to the x is a to the x times ln of a, but technically, let me move on the little picture here. There we go. Technically, there should be a ux, right? So sometimes it's a 2x, sometimes it's an x squared, sometimes it's an x to the 4th, right? The derivative of a to the ux, or to the quantity u of x, equals u prime of x times, and then you can rewrite the way that we've been doing it, right? So we've been doing it, we haven't lied to you really. We've just made it really simple for you because all of these have all been an x. They've been a 1x, so their derivative was a 1, but we could change it up on you a little bit. Here's an example. If I have something like this, right? The inner function is going to be 5x plus 7. The outer function is going to be x to the 10th. So if I find the derivative of this, it's going to be derivative of the inside, which is 5, times derivative of the outside, 10 times 5x plus 7x, 7 to the 9th. I probably didn't say that right. Mr. Perron's probably going to yell at me. 5 times 10 times the quantity 5x plus 7 to the 9th. And then if you wanted to, you could simplify this to be a 50. You don't have to. Same thing here. So normally, right, we'd do secant squared. But if you did that, you would miss the 17 on the inside, right? So take the derivative of the inside first times the derivative of the outside. Same thing here. Notice this is a negative 3x instead of just an x. So e to the x is its own derivative, but don't forget about taking the derivative of the inner function first. Take the derivative of the inner function first. Multiply by the derivative of the outer function. That's the chain rule. Peace.